Welcome to the new episode on data structures. So today we will going to study about time complexity and space complexity. While calculating the time complexity and space complexity of any code, we must remember that one single statement takes 1 unit of time. Let me explain what does this mean. Suppose I write within the main function that a variable of data type integer data type, a variable named a. The time taken to execute this statement is assumed to be 1 unit of time. I will take many examples to make the concept clear about how to calculate the time complexity and space complexity of a code snippet. So the first example that I have taken, suppose this is a function that returns an integer value, that is int sum a and n, where a is an array that I have declared here as total 6 elements from index 0 to index 5, and the elements are 1 5 9 8 8 9. Okay, this array is passed into this function. Now in this function I will analyze the total time taken by the computer to perform these statements. Is assumed that a computer takes 1 unit of time. Okay, so this is a single statement, s is equals to 0. Okay, so this is actually I have taken it as a sum, as a variable that is storing the sum of the total array elements. So this will take 1 unit of time, and then I have declared a for loop, and this for loop has an iterative variable I is equals to 0 and I less than n. This is a condition, and this is the increment decrement statement. So this for loop is running from I is equals to 0 to I is equals to n. From 0 to n total there will be n plus 1 steps. So this for loop will execute for n plus 1 steps. Okay, and inside the for loop there is another statement that is written here, that s is equals to s plus ai. This will again execute, since this is inside the for loop, and the for loop will execute for n times. Okay, so this statement will execute for n times, and return s, this will again take a single statement, so this will again take 1 unit of time. The total time taken by this code, taken by the computer to execute this function, is f of n, suppose, and this f of n is actually is equals to 1 plus 1 plus n plus n plus 1. So this is actually 2n plus 3. Now what is the order of this function? The order of this function is n to the power 1. So this is big O of n. So the time complexity for this function is big O of n. The next problem says, here we have declared a variable p is equals to 0, and for I is equals to 1, p less than equals to n, I plus plus, p is equals to p plus I, and this is within the, this statement is within the for loop. So we want to calculate the time complexity for this function. Let us make two columns, that one is storing the value of I and another p. For I is equals to 1, p is equals to 0, so 0 is less than equals to n. Let us assume that n is some integer value, okay, which is greater than 0. So control goes into the for loop, and p is equals to 0 plus I, that is 0 plus 1 equals to 1. Next, for I is equals to 2, let us also assume that 1 is less than equals to n. So the control goes into the for loop, and it says that 1 plus 2, that is equals to 3. Next, for I is equals to 3, that is 1 plus 2 plus 3, that is equals to 6. And like this, when I is equals to k, then the value of p becomes 1 plus 2 plus 3 plus dot 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 k. Okay, so this is actually equals to k into k plus 1 by 2. Okay, now let us suppose that for I is equals to k, p is greater than n. Okay. What is p? P is equals to k into k plus 1 by 2. This is greater than n. What is the most significant term here? K square. K square is the greatest term. So you can say that k square is greater than n, or k is greater than root n. So therefore, this is of order of root n. The time complexity for this for loop is of order of root n. The next problem, we have another for loop, and here is some statements. Analyze the values of I that are there. So from I is equals to 1, for the first time I is equals to 1, then I is equals to I into 3, so 1 into 3, that is equals to 3, then again 1 3 into 3, that is equals to 9, then 9 into 3, that is equals to 27, and like this. So this is actually equals to 1, this is actually equals to 3 to the 1, this is actually equals to 3 square, this is 3 cube. And suppose that the for loop uh, is stopped for when it becomes 3 to the power k. Above condition, we can say that the loop will stop executing when I is greater than n, 3 to the power k is greater than n. This implies that taking log to the base 3 on both sides, that is k is greater than log n to the base 3. Therefore, the time complexity of this for loop is big O of log n to the base 3. Coming to the next problem, we have another for loop that is running from I is equals to n. For the condition is given as I greater than equals to 1 and I is equals to I by divided by 2. Now in this question also we will follow the same procedure. So we will analyze the values of I. So I, the first time I is equals to n, next it will become I by n by 2, next it will become n by 2 square, like this it will. So then n by 2 cube and dot 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 n by 2 to the power k. Now let us suppose that at n by 2 to the power k the loop will stop executing. This means that n by 2 to the power k is less than 1, that 2 to the power k is greater than n. This implies that k is greater than log of n to the base 2. Therefore, the time complexity for this for loop is also log of big O log of n to the base 2. The next problem is, again we will go by the same procedure. So actually here this condition is important, that I square, I into I must be less than equals to n for the for loop to be executed. So this side we will take the value of I, and this side we will check the condition. What is the condition for the for loop to be executed? For I is equals to 0, 1, 2, dot 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 up to k, the condition that is responsible for the for loop to be executed, that is I square, that is 1, 2, 4, then up to k square. That means that the for loop will stop executing when k square is greater than n or k is greater than root n. So the time complexity for this for loop is again big O of root n. Okay. Coming to the next problem, we have two for loops and we want to calculate the time complexity for this. Let me analyze each for loop at a time. So the first for loop says that from I is equals to 1, this is I is equals to 1, I less than equals to n, I is equals to I into 2. As I have already shown above, it is exactly this for loop is exactly like this for loop. Here this is equals to I is equals to I into equals to 3, and here is I is equals to I into 2. The time complexity for this statement will be also be log of n to the base 2. Look at the second for loop. The second for loop states that j is equals to 1, j less than equals to p, j is equals to j into 2. So for here the time complexity for p is log of n to the base 2, and the time complexity for this statement is log of p to the base 2. That is, therefore the total time complexity is log 2, and within for p we will write log of n to the base 2. Therefore the time complexity for the entire function is big O of log 2 log of n to the base 2. Now so let us summarize that what are the types of time functions. So this is a constant time function, this is a logarithmic time function, this is a linear time function, this is a quadratic time function, this is a cubic time function, these the last two functions are exponential time functions. Whenever we analyze the efficiency of a program, we must always analyze the efficiency on the basis of how much time that the computer will take to execute a program. If the complexity of the program is constant, then it is the best case, and when the time complexity of exponential type, this is the worst case. So for exponential time complexity, the computer will take much time than that of the constant time complexities. So this is the order. The order is from best case to worst case. Suppose you have coded a problem that has a time complexity of n raised to the power n. So it will take maximum time. So I have given a basic idea about how to find out the time complexity of a program. There are two topics left, that is the space complexity and the asymptotic notations, that I will explain later in this playlist. In the next video, we will start recursion. So stay tuned, and if you find this video helpful, then please like, share and comment, and don't forget to subscribe to this channel. Thank you.